Knee injuries are one of the most common sport injuries across all athletes. In the United States, over 750,000 knee replacements or operations are performed, many of which need prolonged rehabilitation. The majority of knee braces that are commonly accessible in market are either costly, uncomfortable, or basic in design. In order to assist with the rehabilitation of patients recovering from knee replacement surgery as well as other knee conditions, our team has developed a unique, reasonably priced knee brace that addresses many market problems. This is the knee augmentation brace from Black Team.
Our goal is to change the way patients recover from knee pathologies and injuries. The objective is to combine the many technologies desired by patients and physical therapists into a functional knee brace such as electric stimulation, resistive training, and cooling, and while maintaining the support inherent in a commercially available knee braces.
Our impacts on the end users are that our knee brace may allow for accelerated treatment of knee pathologies and rehabilitation, requiring fewer doctor visits and resulting in substantial savings. The quicker a patient recovers from an injury, the quicker they can return to an active lifestyle. Beyond the customer, our knee brace creates innovation, attaching multiple technologies like muscle-controlled motor, electrical stimulation, and cooling onto the brace. This drives competition in the market and more investment into research and development, making more advanced features more commonplace in the physical rehabilitation industry. The impact may extend globally as more knee pathologies and surgeries take place worldwide. The effectiveness of our knee brace may also foster advocacy for policies which encourage innovation in healthcare.
In our approach to solving this problem, we first think of a list of customer needs and list them in terms of priority. We gathered feedback from potential end users and created a list of 16 customer needs. We concluded that the three most important factors in a good knee brace are an affordable cost, range of motion limitation, and stability and protection for the end user. We brainstormed ideas and made a morphological chart and integrated the most favorable idea for each feature into our design, made using our CAD software. We also made engineering requirements for them, which are confirmed with our engineering analysis using math, FEA, and our testing plans. Our problem solving entails creating subsystems to improve the healing process and comfort. These are electrical stimulation, muscle-controlled motor, and cooling. We took a creative approach by designing an easily attachable and removable motor, adding a Peltier thermocouple heat exchanger to deliver cooling to our system, and having a TENS unit on board which is controlled by an Arduino to deliver electrical stimulation. The mirrored design of the knee brace facilitates manufacturing and assembly, which further reduces production costs. We feel the design approach taken will provide a novel innovation to the knee brace market.
In order to facilitate the recovery of knee surgery patients, therapeutic cooling that follows the RICE method, or rest, ice, compression, and elevation, is often used in tandem with braces. No braces on the market, however, come with a cooling system that can achieve this, but rather have very large and expensive systems that are separate from the brace. Knee Augmentation Black Team has created an inexpensive, highly portable therapeutic cooling system made from 3D printed plastic container, an impeller-based pump, plastic tubing, and a custom-made knee interface pad to hold circulating ice water. Ice and water are manually poured into the container, and the pump is turned on to start circulating ice water from the container into the plastic tubing and into the knee pad. Water also flows out of the knee pad back into the container to be recooled again. This process happens continuously. The pump also does not need to be plugged in and is battery powered, making it highly compact and highly portable, meaning this system can achieve therapeutic cooling in mere minutes anywhere ice water is accessible. Compared to the average price of $200, Knee Augmentation Black system is less than $50.
The knee brace provides two levels of cooling, one for the therapeutic means and another for comfort. Knee surgery patients that we asked often described that braces overheat on the interface between the pad and the skin. Knee Augmentation Black tackled this issue with the Comfort Cooling System. The Comfort Cooling System will consist top to bottom of a fan, a heat sink, the thermoelectric Peltier cooler, and a heat exchanger. The aluminum heat exchanger connects to a 12-volt peristaltic pump which pushes the working fluid through a network of tubing that connects each pad to the user's leg. This circulates chilled water throughout the brace contact points in order to prevent discomfort for the wearer. This system is intended to operate for 4 hours with the onboard battery. The 200-watt 24-volt Peltier device is capable of creating a temperature differential of 74 degrees Fahrenheit in ambient conditions at full power. Peltier devices generate a significant amount of heat, and thus a heat sink and fan is also implemented to disperse the energy. The high-pressure, low-flow rate peristaltic pump provides ample circulation for the working fluid.
Our motor and electromyography system serves to assist walking and resistive training. This system is meant to be used during your stage in the rehabilitation process, where patients have progressed past immobility and are prescribed range of motion exercises. The three main components are the NEMA case stepper, the stepper interface, and the drive gear. Attached to the stepper interface piece will be small magnets, which will allow the stepper to be added and taken off the brace with ease. The stepper will be driven by a motor controller, which is controlled by the Arduino. The stepper interface is 3D printed, while other components are purchased and modified. The electrical circuitry of the system consists of the MyAware Muscle Sensor 2.0 from SparkFun Electronics, an Arduino Uno board, a stepper driver, a NEMA case stepper motor, and a battery. The MyAware Muscle Sensor 2.0 is an electromyography sensor. The NEMA case stepper motor will be used to assist walking, as it will not be powerful enough to move the leg by itself. The Arduino code tracks muscle sensor voltage peaks to activate and control a stepper motor. If the peaks from the muscle sensor go over a certain threshold, it will activate the stepper motor to its maximum speed set previously by the upper limits.
Our team decided on the integration of EMG, which stands for electromyography, which can read muscle movements using voltage fluctuations, and the integration of EMS, which stands for electrical muscle stimulation, because after consulting a physical therapist about PCL and ACL surgery, it was suggested that users will benefit greatly from staying active and using their knees while it heals, because of course that will be very uncomfortable and painful. The integration of EMS came in because the electrical impulses help the user's muscles contract with little pressure on the knees, alongside the protection and safeguarding that comes with the knee brace itself, can help users walk easier and more comfortably for a quicker and healthier recovery.
The knee brace is composed of 3D printed plastic materials to reduce overall weight and aluminum 7075-T6 metal, which has high strength and machinability components. The aluminum beams are ordered from Sendcut Send. This is an online website which specializes in machining metal parts, and while the 3D printed components were manufactured from a Bamboo Labs printer owned by one of our group members. For the design selection, out of 6 initial designs made by every team member, the final design was selected through a rigorous evaluation process from a morph chart. The morph chart was created throughout the whole semester, where we're just selecting a couple of ideas, putting into one chart, and then eventually everyone selected what they thought was ideal, and the process continued. The group collectively selected the best design, depending on the functionality, the comfort, and manufacturability, and through computer-aided design and finite element analysis, FEA, and CAD.
The knee brace has a center rotation lock made of plastic, which is held by a clip also made of plastic, which allows the user to extend between 0 to 60 degrees and flex between 0 to 100 degrees. These degrees of freedom can be changed progressively as the user heals throughout the recovery process.
Computer-aided design, software, and finite element analysis, FEA, were very instrumental in refining and optimizing the chosen design. These tools allowed us to simulate real-world conditions and ensure the effectiveness and reliability of the final prototype. In conclusion, everything we did to accumulate all the materials using the structure were through morph charts, countless times, and just researching online and then seeing which materials would be light enough and durable and also affordable for the final customer.
Since every person have different leg measurements, our knee brace accounts for proper fit adjustment. The strap connection hook is responsible for adjusting the tightness of the brace for different thigh circumferences. The strap is fixed to one side, looped around, and connected to the other side for the proper fit adjustment. The height adjustable slider is assembled to slide over the main aluminum support bars to adjust the user-specific height needs, where the user moves the cam lock clip position, allowing to slide the housing to the desired height up to a full range of 25 centimeters. Comfort is a crucial part of our design. This was accomplished by constructing a pad that consists of 3 main components. The first is the base Qualex foam pad. The second part is the pad that has the capillary tubes made of silicone having a 4 mm outer diameter to transport chilled water from the Peltier cooling device throughout each of the pads in the snaky motion for cooling purposes. The final part of this is a 94% cotton and 6% spandex cloth casing. This is both comfortable and thin to allow the user to feel the cooling from the capillary tubes. It can be hand washed to remove the built-up bacteria and odors.
We rigorously test our design in prototyping phase and after final assembly. We went through 17 3D printing iterations with detailed design changes made and tested. The feedback gotten from testing the prototype on ourselves and others gave useful information for us to further improve our design. For example, we iteratively adjusted the power supplied to the cooling system to better dissipate heat and changed the muscle-controlled motor's electrical system so that EMG sensors pick up accurate signals and the motor's output torque adaptable to each person's leg swing.